Okay, in this video I'll look at how we can use bond enthalpies to work out enthalpy changes. Quick definition that you need to know is what a bond enthalpy is. So here it is. The enthalpy change that takes place when breaking by homolytic fission 1 mole of a given bond in the molecules of a gaseous species. So it's always about breaking bonds, bond enthalpy, how much energy is needed to break a bond. It has to be gaseous, so if you ever see an equation where it's not gaseous, then that's something else to think about. There could be a follow-on question about why this value is not very accurate. And it's always 1 mole of a given bond, so it can be quantified. When we use this process, we often use the phrase average bond enthalpies, because you'll get a table with each bond and its average bond enthalpy. And for example, the CH bond, which is a very common bond found in most organic molecules, it would be slightly different in every organic molecule. So this is an average of all the bond enthalpies for CH that they have. Some bonds, like an HCl, there's only you only see that once in HCl, so that bond enthalpy wouldn't be an average, but something like CH definitely would be an average. Okay, so the most important thing to remember in this section is that bond breaking is an endothermic process, so you need energy to break bonds, but bond making is an exothermic process, so energy is given out when new bonds are made. So we take energy in to break the old bonds, then we start off the reaction, and when we break up the reactants, and then when we make the products, we reform new bonds, and that gives out energy, and that's exothermic. So let's look at an example problem. Okay, so you're going to get a table like this at some point. You have all the different bonds here that you're going to need, and these are the energies needed to break 1 mole of those bonds, the average energies. Okay, it's always a positive number because it's always the energy needed to break bonds, and breaking bonds is always endothermic. Okay, so here we've got a reaction, methane reacting with 2 moles of oxygen to make CO2 and 2 moles of water. And the important thing to do is when you see that is to draw out the thing showing every bond. Okay, so I draw out the whole methane. There's 2 oxygens, so I draw them both out. And when I do that, I can quite clearly see there's 2 double bonds there to break. 1 carbon dioxide, I draw it out. I can see there's 2 CO double bonds to break. And then this is one that catches a lot of people, 2 waters. So in each water, there's 2 OH bonds. So you've got 2 waters, you've got 4 OH bonds. So we've got 4 times CH, 2 times oxygen double bonded to oxygen, and we've got 2 times carbon double bonded to oxygen, 4 times oxygen single bonded to hydrogen. From this table here, we substitute in the values. Okay, and then I plus up this side and I plus up this side, and these are 2 numbers that I've got here. Now, this side is bond breaking. Okay, we'll break up the bonds in the reactants. This side is bond making. So because we're making bonds here, although we use these values, this is going to be the energy given out rather than taken in. So this is actually going to be a minus number. So we always do this side minus this side, like so, to give us that energy in kilojoules per mole.